examples of expressions involving secant and tangent. We start with expression when secant raised to the even power. Say we have integral of tangent raised to the 11th power x, secant raised to the 4th power x dx. So if you have secant raised to the even power, we want to do substitution u equals to tangent. Then recall that derivative of tangent is secant squared. Solve for dx. Right. And proceed with a substitution. So we have integral u to 11 secant raised to 4th x, and instead of dx we substitute in du over secant squared x. Reduce the power of secant to the 4th and secant squared on the bottom. So we have integral u to 11 secant squared x du. And at this point you recall the connection between secant and tangent, and that connection is secant squared x equals to tangent squared x plus 1. So that's the formula which we're going to be using. And that's expression we're going to substitute for secant squared. So we're going to get u to 11 tangent squared x plus 1 du. You recall that tangent is our u. So now we can rewrite our integrals in terms of u squared plus 1 du. Break that integral into two simple ones. Antiderivative of u to the 13 plus antiderivative of u to the 11 du. Two simple integrals. So we're going to get u to the 14 over 14 plus u to the 12 over 12 plus c. Do a back substitution, u equals to tangent x, and we'll be done. So tangent x raised to 14th power over x over 14 plus tangent x raised to 12th power over 12 plus c. So that will be antiderivative of the original integral. So we see secant raised to even power. The substitution we want to proceed is u equals to tangent x. Another example. What do we do if we have tangent raised to the odd power? So if tangent is raised to odd power, we want to do substitution u equals to secant. Recall that derivative of secant is secant tangent. Solve for dx. So dx equals du over secant tangent. Proceed with the substitution. Tangent raised to a 5th, u to a 7, du over secant tangent. Tangent to the 5th and tangent x will reduce into tangent to a 4th on top. U to the 7, you recall that secant is u, so u to the 7 over u is u to the 6. Right. Now recall that the formula which relates secant and tangent, so which says tangent squared equals to secant squared minus 1. So that's a formula which you want to use. So in our case we have tangent to the 4th. Tangent to the 4th is tangent squared squared. So we're going to get integral tangent squared squared, and tangent squared is secant squared minus 1. Recall that secant is u. So we get u squared minus 1 squared u to the 6 du. Finally, we finish our u substitution. So we have integral in terms of u. Now we're going to finish it. Raise u squared minus 1 to the second power. Square it properly. So if we do that, we're going to get u to the 4 minus 2u squared plus 1 times u to the 6 du. Distribute u to the 6. So we get integral u to the 10 minus 2u to the 8 plus u to the 6 du. Take 3 simple antiderivatives. So you're going to get u to the 11 over 11 minus 2u to the 9 over 9 plus u to the 7 over 7 plus c. And at the end, do back substitution. U equals to secant. And I will write down the answer somewhere here in the middle. So we're going to get secant raised to the 11th power x over 11 minus 2 secant raised to the 9th power x over 9 plus secant raised to the 7th power x over 7 plus c. That will be the answer for this book. So if we see tangent raised to the odd power, we proceed with substitution u equals to secant x, and we're using the property tangent squared x equals to secant squared x minus 1 if we need to take care of tangent raised to the second power or fourth power or sixth power. To summarize, if we have integral of tangent raised to nth power and secant raised to nth power dx, if we have power of secant even, so if n is even, we do substitution u equals tangent, and we use the property that secant squared x equals to tangent squared x plus 1. That is if power of secant is even. If power of tangent is even, n is not even, sorry, odd. So if power of tangent is odd, we proceed with substitution u equals to secant. And we use the property that tangent squared x equals to secant squared x minus 1. Okay. If power of secant is odd and if power of tangent is even, what we do is, in the last case, we do secant reduction formula. Simple secant reduction formula. So we'll discuss secant reduction, how to use that formula in the next video.